My name is Matt Robinson. I'll be your moderator for the evening at Zyrex facility. The Zyrex story and their presence here in San Antonio is a very interesting one. It dates back to 2015 when Zyrex approached Southwest Research Institute to collaborate on the robot you see behind us. And then starting in 2018, Zyrex started working with the Port of San Antonio to conceive of this hangar, to actually host the robot, if you will, house it, enable testing and development. So now obviously we're at the stage where Zyrex has got a working system here, driving awareness here in the community about the story, the success of going from basically an idea, a vision, into something you see behind you today. So with that, ladies and gentlemen, Peter.
Thank you very much, Matt. Thank you for coming up, and I'm very proud that we are here together. San Antonio, Texas Robotics Initiative, and we are the new robotics team here in the Port of San Antonio. And this is, I think, the first time that this initiative again was able to come together. So very much welcome that you're here. Before I continue, let's say something about safety here. You see a big robot behind me, and when we're going to move the robot, and in the end of my story we're going to move the robot, know that the guy who operates the robot has a deaf man switch. That means when he releases the switch, the robot stops. So don't be afraid. And the robot go moving, and you look into it and you say, oh wow. So probably we have to do it twice, the run, we programmed for you, because the first time you look at things and then the second time you look at other things, because it will all move at the same time. So that's already to get you up and running in this presentation. And then at the end I'll show you the robot. The welcome particular here is not only from guests from San Antonio, but we have also guests representing the Dutch government. They are here in the front line behind Paul Evans. One representative of the Ministry of Trade and one of representative the Ministry of Foreign Affairs. And that's also the reason why we have two flags here. For the people who don't know it, but on the right side for you is the Dutch flag. And on the left side is the US flag, of course. And this is particularly interesting from the point of view how international business can be done. A team from the Netherlands building a robot, ending up in San Antonio. I have a presentation and I have a couple of sheets, but they're only used for the photos, just not to read. We are not going into technical details here. So the only reason to have sheets is that it is interesting to show you some photos. And the first photo I'm going to get here. When I was 12, I found in the library of my father, I found a book, 1% inspiration and 99% transpiration. And the book goes about inventors from the steam machine. And Edison is, of course, a quote from Thomas Edison. And so many people in the book are described which are doing some crazy things, new things in the world. But it also stipulates that it is not only the invention and the idea, but it is about the realization of that idea and getting it really done. And I now talk to my father, and he's 89. He's in a caring situation. He's mostly blind. He cannot hear, but I know he's still very proud of what at end his son, 50 years later, put here together. And that always remembers, both feet on the ground, knowing that what you get from your family and your parents are valued, and is maybe a drive you will find in me. So what is this robot doing actually? This robot is solving a problem. Here you see the process. It is filmed in Dubai, and you see the process how an Emirates Boeing 777 is cleaned from its paint. And every aircraft is cleaned of its paint every 5 to 6 years. And the reason is that you want to protect for corrosion the aircraft. And it's nice to look at, of course, nice paint and nice look. See the smurry on the ground. See the amount of people working on it. And see what a terrible environmental thing is going on here. But also look at the people to do that. It's immense and healthy. People who touch that panel there, I urge them to clean their hands, because there's dust on it, paint dust, and current paint dust is still full of VOCs, organic material, which is volatile, and you should not inhale it or keep it on your skin. And that's happening there. So when in 2008 I learned about that problem, I said, can we not find a better way to do this? And you know, modern processes are mostly processes where you need more automation with it, because they are difficult to do. They need precision, they need duration, endurance, they need maybe more weight to carry. And that all is going then in the direction of a robot. So in 2011 I remember a very important call. It was November 2011, and I have a conference call with two particular persons, one representing Southwest Research Institute, and you know Southwest Research because I see here some people from Southwest. Paul Evans here on the front row, director of the manufacturing and robots department, and not he, but his predecessor, I think, was on the phone at that time. And another guy on the phone was somebody from Columbus, Ohio, and that's the laser experts of the US. And they said, Peter, when you want to strip paint from an aircraft with a laser, we have one good message and one bad message for you. And the good message is, there is a laser which can perform that and can do that, but that laser is new. It's built in Germany, but that's good news because it is very strong, very powerful. It will help your business case because it will deliver you a process twice as fast as the current process is. And twice as fast as the current process means the aircraft less on the ground, which is the key business parameter for cost. He said the bad news is we have to build a robot for that. We cannot buy a robot in the market to do that, because the laser beam needs to be transported inside the robot till it gets to the aircraft. So the robot behind me has a path inside the robot where an 8 centimeter laser beam, for you 3 inches about, is transported through the robot to the nose at the end, where it gets the beam projected on the aircraft, and there it removes the paint by combustion of the paint. So think about it. The laser goes through the mast, through the arm, through all the elements here of the wrist, and gets up at the end and projects a small spot, laser spot, on the aircraft. And that is in the end how the laser works. When you have the idea that you are combusting the paint from an aircraft, you can also suck away all the gases coming from that. You lead through the robot, again all the gases, the residue gas, and then you can filter at the end till you have clean air. So you have no residue anymore. You saw in the video the green stuff laying on the ground, 10 cubic meter water, cubic, maybe half cubic chemicals. You have to process it to clean it up again, reprocess it. Here at 777 delivers about 1 pound of residue in the filtered unit. That's the only residue we have at the end. So very clean process. Nobody is involved anymore. So no dangerous chemicals in contact with people anymore. And it's twice as fast. So it's a good business case. Well, see the Zyrek business case we had in 2015. In 2015 we needed a lot of money. So we looked around and we found a private investor, but we found also the Dutch government. And that's the reason why the Dutch government is also here because the Dutch government provided us a loan for innovation, and after 6 year work, we probably can say that a month ago we officially mentioned to the government that the project was successful, and we are obliged now to pay them back the loan. But we do it proudly, because when you loan something and you can proudly give it back, that's a good idea. The word investors are mentioned. So we had investors. And every time we needed more money. You know, maybe about innovation. When you talk about innovation, you find out that in the middle of the project, it is not as you thought it is. You have to redesign it. And here you see Paul Evans in the front, on the right side, the director. Of course, he is standing for his team, looking positive into the camera. But his team, well, it was not completely showed, I can tell you on this photo. They feel really that they work hard. And we had many issues to get it up and running as it is currently. And that's part of a complex innovation project. And sorry for the persons here which are interested in technology. I cannot talk in 30 minutes about the technology of this robot. It's impossible to do so. So when somebody says, we want to understand it a lot better because we have interest, Peter, in some of your technology, you're welcome to talk to me, and we can make an appointment and we'll run through thousands of PowerPoints. Yeah? That team delivers also that we have 5 innovations. And those innovations are patented. And currently, I think of the 5, we have now 3 of them are already agreed to. So we are heading away in unique solutions. And I can tell you, every time I thought, hey, this is probably a patent filing valued, then I thought, well, that sounds easy. And in the end, we came down, well, it is not easy. Every time we found issues with all those implementations of those patents. But we solved them. We solved them. And then you have this design ready, and you want to build it. So where do we build it? The components are all mostly coming from the Netherlands, come from Germany, Austria, Japan, Sweden, US, other parts in the world. But where do we assemble it? And then Southwest said to me, Peter, you know, there's a port here, and the port of San Antonio, well, they are maybe willing to help you with that. So we made contact with the port, and actually it was a quick action there. The port said, Peter, we will support you. We built for you a hangar on this area. And hey, that's lucky, we have Boeing here. Maybe you can use one of the hangars for testing. Okay, that's a good idea. Let's ask them whether they can use one of the hangars for testing. And they agreed to for that. So we had a hangar and we had a testing facility. So we needed an aircraft. So on the Kelly airfield here, 2 miles from here, we have our own Boeing 727. I was personally here when the aircraft arrived. It can still fly, for all people who are doubting that. It's still airworthy. And this aircraft we're using in the last 2 years for testing the robot on a real aircraft. Future customers all expect that we can show this complete new system working on a real aircraft. That's the condition they have. And you see, the company took care of that. They always ask me, Peter, tell me what is the cost of such an aircraft? I said, well, you have to find out yourself when you want that. In July this year, we had the final test. And it took a lot of work. I've been 7 weeks in June and July here. By the way, I was also in February here when we had this snowstorm in San Antonio. I was locked up in my hotel room for a whole week. When I arrived, it was 70 Fahrenheit. And then 3 days later, it went down to minus Fahrenheit. And I had no clothes for me in any way. I was on summertime clothes. So I was locked up in my room, and every morning when I woke up, I was checking the light because do we have power or not? And then I tried to shower, do we have water or not? So, and I was lucky. I was a lucky guy. I had no issue. But since that time, we worked hard to get the final results with the robot. And the final results is actually on that panel there. You see paint removed there, and you say, yeah, but not all the paint is removed. That's the reason is that we made the paths of the robot paths a little too far away from each other. Else it would be, when it would be an inch less, then all the paint would be removed on that panel. So that's the reason, our own fault in that the path was a little too wide set up. But the result is that we were able to remove the paint. The result is that we were able to do it in the speed we need to do it. But before we got there, we even had to replace the laser system on the robot. We flew in a complete new laser in the beginning of June from Germany, 5 metric tons air freight. And it's a nice invoice you're getting when you do that. But we needed to do it because we need to show that it worked. And on 29th of July, we have been successful. The laser and the system worked ininterruptible, continuously. And actually, I can tell you, all the people looking at it got bored. After 10 minutes, you see it, you say, okay, robot is doing it. What else? Is there something more to happen? No, there's nothing more to happen. The robot is just doing its job. That's the good news. And you see that we operated here in this hangar, no people around it. It's strictly forbidden. Laser is very powerful. From here we could, with the laser, we could take the tower, the top of the tower down. So we don't do it. We don't demonstrate the laser on today for you all. We're not worried about that. And when I tell you that, when I went back to my father, when I came back after 7 weeks here in August, I told my father, hard to communicate, well, he's deaf, but okay, I managed. I said, well, it works. And I was happy that I got his right reaction to that. So it worked. What he tried to do worked. Run it? You have to run it. Is that it, where you come from? Is that the reason why you're here, to run the robot? So what said Captain Kirk, let's engage. And watch it. We are now at 14 meters high, about 40 feet. So full automated, he just pushed the button and it ran itself. And the next action we do with the robot is in the big hangar here on our own aircraft, and we remove the paint of that aircraft with this robot. So maybe you think, hey, this is then SATX, but SATX is planning, of course, more. Because when you remove paint, the next step is that you think, hey, can you not use the robot for painting then? But painting with robots is known subject. All the big robot companies deliver robots for painting cars. So painting of cars is robotized, everybody knows that. So is there something what we can deliver unique as SATX to that process? And in 2016 we came to a very great idea. We made a new technology. It's actually, simple said, an inkjet printer mounted on a robot, and we use that inkjet printer to paint decorations in any color on an aircraft. This is a fast video, of course you understand. But think about what here happens. And actually, you saw the speed, but we are not that far away from the real speed than you showed just. It means that we can, with this new head, it prints with inked decorations on an aircraft. We can redecorate an aircraft in 2 days. And that will change the world. So every time you look around and you see an aircraft, American Airlines, Delta, United, Southwest, 3 colors you see. And why you see 3 colors? Because it is cheap. Because every color you add is 12 hours longer in the hangar. And that is a lot of money. So 3 colors, cheap. In India, in China, in Asia, they have all 8 colors on the aircraft. They love colors there. But there are new companies, so they don't have this limitation from 30 years ago, 3 colors only. With this technology, you will see the change in the world, because also US operators will embrace this. It means that you can add advertising on your aircraft, change any message you put on an aircraft, and 2 months later you always replace it with another message on your aircraft continuously. And this technology will be coming up in 2 years from now. And you see the robot already. Take your thinking, and you take away all the laser stuff, and you add this direct printing unit, and you're there. So you see here a little future look what SATX is going to do, and the engineering team will be here in San Antonio for that. We will assemble the robots for you in San Antonio, and we will rely on the port of San Antonio for the support on all the facility requirements we have for that. And that's all foreseen in the coming years. Thank you for listening to me. I think the next step is Matt is going into a panel discussion with us. Thank you very much for your attention.
I'll start with Paul Evans with Southwest Research Institute. He's the Director of Manufacturing Robotics Technologies Department at Southwest Research Institute. He's got his mechanical engineering degree from Iowa State, and is a PE here in the state of Texas, leading the technical development role in the field of robotics and then transitioning into leadership. As I noted, he's our director, specializing in robotics, automation, machine sensing, perception, and process improvement. We have program areas focusing on flexible automation, intelligent machines, and implementation of a variety of robotic solutions, including custom, large-scale and mobile solutions. And of course, his department was where the Ross Industrial Open Source Project was founded by Paul Voss and Sean Edwards when they were on his team. That came out of the department at SWERI. So welcome, Paul. Next, we have on the end here Paco Felici with the Port of San Antonio. He is currently the Chief of Staff and Chief Communications Officer here for the Port of San Antonio. Before that, he was the Director of the Nature Conservancy of Texas. And between 1993 and 2008, he served in numerous capacities at the Office of the Attorney General of Texas. He's earned his undergraduate degree in English from the University of Texas in Austin. So these are our panelists for today. So I'll be moderating a little bit of discussion. Again, I'm Matt Robinson. I'm with Southwest Research Institute as well. And I have a few questions to kind of get things started, and then hopefully we'll have some time for Q&A from the audience. And talking about with our panelists, it's basically, it's a little bit open-ended, but what does this development, you know, everything you went through and where we are today, what does it mean in the context of where we are today? Peter, you want to kick things off?
Yeah, shall I? Well, you can look at it from technology point of view, and you're saying, hey, this is the first large industrial machine, and you can do all kind of work with this industrial machine. But it also means that we we got there. And let's think about it a little. So we have a business, we have a view in the business, we have a technology view, but you need also then an institute, an R&D organization capable to implement that. And this second thing you need an infrastructure supporting all those activities. So actually, what you see here is Southwest Research Institute, you see the port of San Antonio, and you see Zyrec as a business and with a vision, and you see it coming together. Without Southwest Research Institute, without the port, we would not be sitting here. And then people ask me, but Peter, when you were in 2008, you looked into this problem. Did you already thought that it would happen in that way? No, no. A vision is something, a strategy and implementation is another thing. And I'm very grateful that we found in time, every time, the right action. We found Southwest Research Institute as the leading institute in robotics in the US. And in 2018, they helped me to point me to the port, and we found the port, and the port was exactly in the right mind and saying, hey, we can help you with a facility because you need a facility to assembly. And I can tell you, I get daily emails from around the US want to facilitate us after it has been successful. But being with them before you are successful is the real job. It's always about who steps in when it is needed instead of, no, too much risk, no, we don't know, we don't believe in it. And in the end, when it is done, they are willing to put their energy on the table. But that's not helping companies like Zyrec.
Does any of the other panelists comment?
My take on this is going to, certainly would like to follow up on Peter's great thoughts, which is that every great technological journey takes tremendous courage, tremendous vision, rather big beyond the here and now as we've known it. And that is the essence of what my colleagues and I hope that we're building here at the port, which at the end of the day, if you just look around you here today, is clearly a sense of community, because all of these great journeys, and we heard from Peter during his presentation, and as he just alluded, it's going to be a bumpy ride along the way, and it's going to take people from different perspectives, different disciplines to help you along in that journey. So as we look around here today, I was just, especially now that we're coming after a year and a half of being sequestered in our own physical and maybe mental spaces to a degree, to finally have opportunities right here. And particularly, it is so invigorating to have a gathering like the one that you've created here today, because I was just struck over the last hour or so as people were coming in, how we have people that are so representative from throughout the community, and how many current stakeholders we have in this particular project. But as I look around me, and I think Peter probably feels the same way, that we see the opportunity to connect up with future partners and future generations. So, honored and humbled to have Sueri, of course, at the table to have made this project happen, but to of course have our other fellow roboticists. We have our friends from Hatchbed, we have our friends from Plus One Robotics and others, and then to have Camille, who is 6 years old. Camille, where are you?
Oh,
Out there. Hey, Camille. We have Elijah. Earlier, I had an opportunity to meet with some new friends over here, and again, the English major being asked if this thing was going to go up into space. And I smiled and nodded, and I said, I don't think this one is, but I know that Peter's probably thinking about it, and probably a lot of other folks in the audience can better answer that question. And so this, today, and what you've been doing, Peter, and what you're taking us, are really the essence of what we're trying to build here at the port, which is not your standard redevelopment, not your standard economic development authority, but to leverage what we can in terms of the levers that we have, i.e. delivering this kind of highly specialized place, which of course you're at the end of Kelly Field, and that provides you with a tremendous competitive advantage as you scale your company up. But at the end of the day, to also ensure that we're connecting up with folks here within this community and beyond. And I'm saying this not out of a sense of drama, and I didn't plan this, but as I was out there, as I usually do, catching up with emails through the Eventbrite site, I got an inquiry that I just emailed to you from someone internationally who wants to talk to you about this thing. So
Good, good. Always welcome, always welcome. Everybody interested to talk to Cyrec, welcome please, of course.
thank you for bringing us this far, and we're very excited about where you're taking us.
I guess,
It will be hard for the Port 2 in the coming years.
what does it mean for the future of robotics and in aerospace and beyond?
Okay, so I mean, this is kind of open-ended, right? I can take this where we want to go. So what does this mean for the future of robotics? So, I think about some of Peter's slides that he prepared where, he said, everything wasn't always so smooth, and that there were challenges at times where we had to get in the room and solve problems, because when you put together, it's not just any one item by itself that's a challenge, it's when you put together so many different systems together and make them all work as one, that's the challenge. And I think one of the things that I'd like to say that we showcase through this system or the solution is that it is possible, it is feasible to take things that are in and of themselves individually complex and then add them to other complex systems and solve big picture problems, right? And so I think that's one of the key takeaways. There's many times where you could go down a particular path or a trail and think that this is the right way to do something, and then you recognize through the collective team working together that at some point you have to cut and move a different direction. And I think another piece to recognize relative to where does this go for robotics, and particularly for the San Antonio community, is that you can leverage your relationships and be able to reach out to somebody that can connect you up to another person that they know, to another person that they know, to help you solve some particular problems or challenges relative to a technology need or a gap. And this community in San Antonio, I think, is particularly well skilled at that, where I know there's a lot of people out there that I can reach out to, and they'll make introductions and help us solve problems. And we've experienced that along this journey.
I mean, Peter, do you want to comment on that, about the future of robotics for aerospace?
Yes, it is a large story. Let's make two statements here. The first statement is, I think that Cyrec will have a very interesting future with headquarters in San Antonio. The US market has a lot of opportunity for this kind of robots. And it starts with aerospace, but the next step will be, of course, marine market, ships, and public infrastructure like metal bridges. Every object, it is painted, and when you want to replace the paint, needs to remove the paint, and it is, from environmental point of view, it's a very bad thing when you just let the paint go. And I think it's in the very near future. It's already in the Netherlands going on. They cannot grid a bridge anymore. It's not allowed to do it anymore because the paint with the grid just falls into the river, and it pollutes the whole river. And well, when you never drink water, you are not interested. But everybody drinks water here, and you are interested that your water is fresh and that we can keep it fresh. So lots of opportunity there. And you talk about tens of robots in the US. You talk about big future here in San Antonio, the assembly location for the US. But from here on, we will going into rollout in Europe and in Asia. So that means large company, they have a lot of effort, but also a lot of money coming in. And that gets to the second point, that Cyrec will use its means to make the robotic world in San Antonio bigger. I have a very strong vision to create a San Antonio Robot Valley. That's a valley where robotics companies are together, working on different subjects of course, but are working together from skills, from ambition, from financing that ambition, from sharing knowledge so we can improve our products, by using each other market position to create new market positions. And I know that we need a driver for that, and I know +1 Robotics there, and some other robotics companies here in San Antonio. Together with Cyrec, we will be able to really get this off the ground here. The San Antonio, Texas Robotics Initiative needs a big driver, a big business driver, and I'm willing to pick up that ball. And it's not today, not next month, but slowly we will get there. And the year after we do more. We will open a headquarters here, and the headquarters will have space available for new startups. And Cyrec will support those startups with financing those initiatives. And maybe it's also for Cyrec interesting, but it's surely interesting for those initiatives to grow and to make more business in San Antonio. And that opportunity is here, and it is at this moment to grab it. As we have done here the job on making 6 years to get this robot up and running, let's talk about 5 years from now again, sit here again, and see what we have achieved in those 5 years. San Antonio Robot Valley, that's the term I like to push.
Well, thank you, Peter. I guess to continue a little bit about extending the tie into San Antonio, this notion of obviously we have a robotics community both obviously around San Antonio, hence this meetup. But I guess, Paco, to follow up on, continue pulling a little bit, I mean, right, the port seems to be aligning itself with fostering and enabling technological innovation and providing a place for it to call home.
Yes, sir. That's exactly right. And then just going back to your earlier question as to where robotics is going, and again, this is the take from the least technical person. And the way my colleagues and I see it is that the future of robotics is going to, in no small part, be determined by how well we bring together the robotics experts and then the people within the community, around the region, across the nation and around the world that have challenges that robotics can address. And everything that we can do to facilitate those conversations, to have demonstrations where questions can be asked. Can this robot go up into space and do stuff? I mean, those are very, very important and a very thought-provoking prism, which we hope continue, please do keep asking those kinds of questions. Then people will be able to convene and start thinking of ways in which those applications can happen. And the more fluid those conversations are, then the robotics community will be better enabled to come up with a solution with a fix that more readily, more immediately addresses those issues rather than operating in a vacuum. So today we have Peter focused on the aerospace industry, but he already alluded to the naval applications that this will have, and I suspect that in Peter's own universe that there are still some opportunities that we might have not fully thought through, but over the course of being able to have these gatherings, these conversations, and that being one of the focal areas of the Innovation Center, which we're going to be launching with the San Antonio Museum of Science and Technology in the spring of next year. It truly creates a town square where everybody has a voice, everybody has a learning experience, one from the other, and that ultimately is what drives forward innovation. And as a value proposition, it starts pivoting San Antonio, which has had these tremendous silos of expertise tracing back 100 or more years. If you look at aerospace, if you look at cybersecurity, if you look at personal computing, if you look at biomedicine, so many of those innovations were deployed from here. And the way forward is breaking those silos, having those conversations, bringing other expertise and applied technologies to the table, and allowing our community to access the global markets even more fluidly, and more importantly, to compete globally, not because we're the cheapest place to do business. There's frankly a lot of other places around the world that can compete against us from that standpoint. We want to compete based on the value of the products and the ideas and the innovations that are fostered.
You know, take it a little bit back to a little bit technical, but I was wondering if some of the more technical oriented members of the panel might give a thought to maybe like what are probably in your mind like one or two of the key technological advantages that we wouldn't be here today if we didn't realize that.
Yeah, that's a great question, because there's so many that we could talk about that. But you could talk about robot side of things as well as process, or as well as industry, right? And so maybe we'll talk a little bit about the robot side. You know, without the kind of the increase in power capabilities for the laser technology, I mean, we really wouldn't be talking a lot about this as the advanced technology that we can go and make a big difference financially to the aerospace industry from you know, how fast the robot can do its job or strip its planes. So I think that's one of the key things, and we've seen a lot of great advancements in laser technology over the years, where finally this is, you know, enabling us to go and do good work with a high power laser versus something that, you know, just wouldn't make a difference relative to the number of people that you would need to, you know, depaint a plane. So that's one of them that comes to mind, is just laser itself. Peter may want to jump in and think about that too.
I have a vision in that, and it was not 10 years ago or 12 years ago that I came up with this vision. This vision is actually quite recently, and it is that when you in the end said to yourself, what is this system actually doing? This system is creating, with a new process, with this robot, a CO2-free, complete, environmental, friendly, healthy work situation, work environment. And that is a crucial, I think, when you recognize that by combining these technologies, you are instantly now able to reduce any use of any chemicals, reduce dramatically the amount of fresh water you need for the process, and you can do it better than humans can do. So less risk of damaging an aircraft. And even it is faster. So the operators, and they had it a very hard time last 1.5 years, they can also get a benefit from this process. So think about that. What would be my next project? My next project will be a robot, again with a new process, which again changes the way how it currently is done, by no CO2 output, no environmental issues, and no unhealthy work anymore. And when you can introduce that into the society, into manufacturing, it would mean that a lot of people are less injured. Health will increase. Your whole discussion you have, and it is daily in the papers, about the environment, it will be supported with those new technologies. And this is the first example I know of which is available. And I foresee that with R&D institutes, we will work together with R&D institutes to look into processes in manufacturing, saying, hey, can we not change that process by another process and using a robot? And by that helping society, instead of only looking at the business side of a business case. And I look forward to work on that. And I can say that, for instance, we are working currently on a new hangar concept, a new aircraft hangar concept, where the aircraft hangar is not using any more natural gas or power, external power source, complete microgrid, self-sufficient, using its power, and the CO2 output of that hangar operation is 0. And that's, I think, where we should go for. And is it costly? No. No, it's not more costly. It needs somebody to do it. That's where we talk about. And I'm looking forward to be that driver.
Excellent. Thank you, Peter. I'd like to actually open it up to the crowd. Are there any questions for our panelists today? We got a hand right here. I'll come with the mic.
My question is, with SpaceX using reusable, creating reusable rockets and everything, have you thought about using this? Have you marketed yourself for customers like NASA or SpaceX or somebody like that? Have you thought about, doing this with that industry?
Well, I'm aware of problems they have with the Minuteman rockets you have in the US for your defense systems, that they need repainted, for instance. And it's hard to repaint such a large rocket systems. Somebody asked me a year ago, Peter, you have a fantastic laser here. Can you not use it for, let's say, for defense purposes? And well, I think that's not where this laser is the best solution for.
I mean, I think that emerging industry is just only growing, right? So as we think about where space is going next, I mean, there's a lot of discussion about manufacturing in space. There's a lot of discussion about, doing mining on the moon. So when you think about all of these kinds of things that we need to go do in the future in space, and you think about reusable space vehicles, it makes great sense that this could be another solution for another, if you will, maintenance and repair operation that is kind of focused around the space industry. So I think it's a good comment. Yeah.
Maybe I recognize something in the question now. When people ask me, when they look at a robot, they say, what is the robot actually? I said, well, it's a big machine, that's for sure. And with an electrical background, there's about 20 miles of cables in it. So electrical guy says it's a huge electrical system. And the IT guys here says, no, it's a very complex IT system actually. And when you look at the values of this robot, and you look at it from a technical point of view, when I look at new futures like space operations or mining on the moon, the key there is not the mechanical presentation, the key is the software side. And this robot has really the last of the last technology on IT implemented. In particular, Ross Industrial based, it's the largest machine, Ross Industrial based, but also the feeding of all the sensors to an open structure. At the end, reporting with just basic Microsoft environment. An HMI, which is really open structured, gives you a lot of opportunities to implement all this software on any system you can see in the future. And that maybe it's not visible, but there is a lot of innovation in that aspect which you can use in other areas, in domains.
I'm wondering about annual maintenance, the cost of annual maintenance versus general labor.
We have some ideas about what annual maintenance is, but in principle the robot is designed to work 10 years continuously. That means that normally a robot as this is not utilized 100%, it's utilized maybe 50% or 20% in the real world. So the robot can probably run for 20 years without real serious issues. There are parts, of course, which you have to check, because you can have a motor which breaks down, or you can have a piece of the laser system which breaks down. So you have to do preventive maintenance. We expect that we have to do that 2 times a year, a couple of days.
Would it be feasible to implement features probably in the future that also scan the structural integrity for like warping and cracks and stuff like that?
Yeah, that's a very good question. That's very drag-along solutions you can think of such a robot. So our next robot after this model is removing paint. The next robot is painting, and that robot will have not only a paint function, but will also have an NDI function, non-destructive inspection tool. So one of our ideas is that you can run a complete inspection of an aircraft. It's not currently done. Currently, inspection is done on visual inspection and then orientation on the aircraft where the issue is, and then maybe with a tool finding out how much issue you have. This robot, in this type of robot, can run with an aircraft the whole night and look at all the aspects of the aircraft, finding integrity issues by implementing it in an automation. Yeah, that's one of the upcoming solutions.
Is it able that the robot can be different colors?
I selected myself this blue. I can tell you why I came to this color. It's actually based on a color of a car. I saw this car color and I said, well, that would be a beautiful color. It's signal blue, officially named, and it looks good on a car, so I thought it looks good on a robot too. I can tell you, we get requests for different colors because sometimes companies have other ideas about the color of a robot, but they have to give me a lot of money for that.
It is a funny question, though. I mean, how much time do we spend talk about robot color? So what's your favorite color? Right, maybe that'll be the next one.
My favorite color is red.
Okay. I was just quite amazed by how quiet the robot was. Usually these contraptions are really loud, so I was wondering how were you guys able to do something like this? Just make it quiet.
Out of the box, initially, when we first turned everything on, there was a lot more servo noise than that, right? So, and that probably doesn't surprise anybody that's done robot development when you're building a custom robot where you're implementing the motors that you sized and trying to tune everything up. But I think the key is the devil's in the tuning details, right? And so there's a lot of parameters that you can change or adjust within the system that gets you to the optimum kind of setup for the particular servo motors based on the loads and inertias and things that they're seeing. And we've spent a lot of time tuning those motors to where you get the performance that you have now. So, yeah.
But it is quiet, eh? The robot is very quiet, eh? Yeah, much more quiet than you buy an industrial robot.
Yeah.
Yeah, correct.
Thanks. I have a very basic question. Can it work with all kinds of paints? And the more basic question is even, where does the paint go when it's off? Is it sucked in?
It can remove all organic paints. Doesn't matter what color or type of organic paint it is. But at the end, it must be organic. That's the key. And I'm not aware of other, but you don't, non-organic paints, you don't call them paints actually. So, and where it goes, well, it burns, and then we suck away the burning gas, the effluent gas. We route it through the robot to the backside of the robot, and when you take a look there, you see a big filter unit, and it's a three-phase filter unit. It filters the air back to the air quality level you need in California. This is the highest of the world. And like I said, on a Boeing 777, we end up with about a pound of dust collected in the filter unit, and the air is pushed back out of the robot. There's a smokestack there at the robot, and the only thing coming out is CO2 and CO. In principle, that is.
What's the range of motion on some of the wrist axes? On some of the wrist axes, like how much can you wrap it around or something?
So we have an 8 degrees of freedom robot here, and the first 7 are you see the base of the mast can rotate, and then from there on you have 7 axes, and the last axis is. Wait a moment, oh, now I'm getting into my role. Wait a moment. Wait a moment. I hear, let's see whether this works. Yes. So, now I'm getting into, my father was a teacher, huh? You have to know this. So a little explanation. This here is axis 1. It rotates the mast. Okay, can you see it? Rotates the mast. And then we have here, up and down, is axis 2. And axis 3 is rotating this large arm, and it rotates, and you saw when it was over there, you saw that the rotation was upwards. And then axis 4 is the translating of the arm forward and backward. And you see from that point to that point is 12 meters. It's, what is that, 38 feet. Then you see here at the end, we call that the wrist. We have here the first, axis 5. We have here axis 6. And we have here axis 7. And this is axis 8 here. And till 7 is actually to get the robot into the position against the aircraft. And the last axis, axis 8, is only to turn around the direction. So when we go in one direction on the aircraft, we can move around axis 8 going back again. So we don't have then to return the whole wrist to turn. We don't need to do that.
So,
Yeah.
so 8 has a range of motion about 180 degrees.
Axis 8 is 180 degrees. Yeah.
And then
Can
7
turn
and
complete
6
around.
are about 180 as well?
270.
Oh, 270.
Yeah.
Thank you, Peter. Good.
And
good.
you have seen the cable carrier around it. Yeah, it's a very fancy cable carrier, isn't it?
So good afternoon. My name is Emmett D. Decker, and I actually have a very interesting question. It's more of a social question. So something that I've noticed about just everything in general, about how humanity works and how humanity operates, is that basically, you know, capitalism operates because people have motivators to want to do something. So for instance, you know, my understanding is that human beings aren't just going to come together and randomly just say, oh, I'm going to put a bunch of pieces of metal together and stepper motors and electronics and microcontrollers and build this robot. There has to be, of course, a motivator. And that's what I think is really, really amazing, how human beings can come together and do these things. But one thing that I've noticed is that as somebody who wants to advance humanity and wants to make the world better with technology and engineering and robotics, whenever I look up, for instance, Elon Musk or people like Terry Lundgren or famous business people who have been able to own the means of production for the betterment of human civilization, I've noticed that they have all come from something. All of their parents are either famous business people, or they've come from people who have done something already, or they've had connections to something. My question for you is someone who, of course, you know, does or is involved with the management of capital and, of course, with the management and ownership of the means of production, what advice could you give to someone who, because, you know, there's billions of people on Earth who all have their own goals and dreams and ideals. You know, some people like chocolate ice cream, some people like vanilla ice cream, some people want to improve humanity, some people want to live the bare minimum, put in the bare minimum amount of effort to have a happy life, and some people, who are really weird, just like me, want to marry a handsome actor like Michael Douglas. So what advice would you give to somebody who wants to enter the world of high society and advance humanity and build capital for him or herself, who didn't really come from anything? Do you have any advice as, you know, a business person or as somebody who has been able to do these technological breakthroughs for someone who wants to, in the future, when they grow up, to do these technological breakthroughs? What advice could you give to a young person like me who is interested in these things?
Yeah, thank you for the question. I think it's for everybody here a personal question. You heard a little when I started the story of Sarvik a little with my father told me and pointed me to a book, and nobody could say at when I was 12 what I would do in my life. You could maybe say that, well, he did good on school. You could say that, and I think that's the first objective you should have. try as much as possible get education. And when I speak to young people and they have a choice between what I'm going to do I go into arts or do I go into science or engineering, I advise those people to start with engineering and science. Not because I don't think arts is interesting, my mother was an arts teacher, but that's something you can also absorb a little later in your life. But engineering, you need a lot of basic mathematics and physics background there, and it needs to be active to pass those studies. And when you're younger, you have it easier with that. Then it is up to you what you do with it. And when people say, Peter, but you are a startup, running a startup, but you are not the youngest anymore. No, I'm 60 years old. But I can tell you, I live like I'm 20. I have so much ambition. And that ambition at the end leads you. So, do you have ambition? I cannot answer that. When you have it, use it. My parents educated me well. They did not give me a lot. They did not give me anything. I had to earn everything. And when I had a good idea, they supported me, but I had to do it myself. And so they trained me well to get from ambition into execution. So I hope your parents are helping you with that, or maybe you have a mentor can help you with that, or a partner helping you with that, and drive and go for it. That in the end go for it.
Excellent, thanks, Peter. I'd like to think that events like this help too, right? We need our network. I mean, Paul touched on it. You know, being here in San Antonio, we have events like these. We have our communities. We have the robotics teams we're parts of. Different opportunities to get together, share ideas, and work together. So I think that's a really great point. Thank you, Peter. Thank you, Paco. Thank you, Paul. Thank you, everybody who came here today. We've got a little bit of time. Feel free to talk amongst yourselves, meet a new person. That's kind of your goal today. And we'll be announcing the next event shortly. So stay tuned. We look forward to a great upcoming set of events for SATX Robotics. Thanks, Peter, for hosting us. Paco, it's been great meeting you. It's been great to work with the Port of San Antonio. Thanks, Paul, for giving me a little bit of time today to prepare for this. That way I didn't get in trouble. So I look forward to chit-chatting with you guys after we conclude here. Look around, ask questions. Peter will be available. Have a great evening. Thanks for coming.
Thank you very much.